Hi, this is Sundaresan. I'm head of QA and DevOps at joinassembly.com. Today I'm going to talk about API security and pen testing, and hopefully you can jumpstart this journey if you aren't already security testing your API. Of course, we all know that API drives our economy today. Your mobile applications, web applications, IoT devices all depend on APIs for it to work. Your public transactions when it comes to payment or any sort of transactions like filling in a form, or there is an analytics website that actually collects some sort of a data. Your single sign-on, especially across different websites on mobile devices, um, when it comes to even comparison shopping, everything is driven by APIs, right? I mean, without an API, you really cannot actually stretch the limits of transacting information across different devices or different websites or different engagement areas, right? But what if there is some unethical access to this website through which the data gets breached? There are security implications which can cause a lot of heartburn for both the organization as well as the users of the organization, right? Hackers love data because data is the new oil, and with this data they can do anything. So they love data. They would like to make sure that there is an API out there that they can hack and get this data out so that they can sell it back into the dark web. So we really need to be cognizant of the fact that if we do not security test our API, it's going to be a disaster later. So the objective of the upcoming slides is to help you look from an attacker's point of view when you do your day-to-day testing, and then some amount of interaction when it comes to tools and examples. Of course, there is a lot of information in terms of API testing out there on the web, but at least this should help you to kind of open your eyes and jumpstart your journey around it. So yeah, when it comes to security testing and API, look at the attack surface. Attack surface is something that a hacker does, but you should also be aware of the attack surface as to what is the intended use of the API, and does it end up leaking a lot of information to the user. And then what is the attack area of the API, basically what are the authorization limits of the API so that it doesn't actually expose the data for an unintended user. So these are some points that you may have to actually note down before you start testing your API itself. Of course, we all know the construct of an API. Today we mostly use a REST API or a GraphQL API, but both works from a HTTP layer or HTTPS layer with the host name, path, query, and parameters. But everything can be tweaked, and everything can be tweaked by an attacker to kind of get information around it, right? And there are tools to do it as well, right? And then look for the information shared in the headers. I mean, an attacker can actually try and change a JSON response to an XML response in their query, and then your server may not understand it and might end up giving out anything that they want in the response instead of an error message. So what happens in this case? So start looking all this from an attacker's point of view. Create your attack surface. Note this down, document it, and then start security testing your API. So some of the key areas that you may have to look into is the authentication authorization. Trust me, the first attack surface that a hacker will actually get into is to look at anything that is already exposed on the web through your GitHub or any other repository that is exposed on the web. So look for your tokens that might be exposed in GitHub internally as well as externally through any of your customers who might be using your API's authentication tokens. Chances are that they may be sharing the token or storing it in a repo, or they may also be exposing their API authentication keys that might actually be helpful to generate a token, right? So as a starting point, internally you can look through in your Git or your repo or grok your repos to see if there are anything that is exposed. Then the other biggest attack surface is actually Postman public collections. There are a lot of organizations where developers and test engineers actually share their public collection between each other without knowing that they are also kind of exposing the authentication tokens. Chances are that the tokens are long-lived, and they also expose their internal URLs where they may be testing the APIs, maybe on a public cloud, and then an attacker might actually end up jumping into your internal test bed to test it, and then maybe use the same parameters to go ahead and attack the publicly exposed URLs. So look for these areas. This is the primary area, I mean, apart from social engineering, where an attacker will actually start their attack surface. And then look for privileges. Once authorize, try and decode a token. If you use a JWT token, your JWT.io website will be able to decode it and show you what sort of authentication and privileges are there. Make sure that the privileges are encrypted and cannot be easily decrypted, or it's not very legible for anybody to read. But chances are that it might also expose a few other areas in terms of the privileges itself as to which APIs this particular token has authentication or authorization to. So these are some areas that can get exposed. So try and decode your API token. Your token can be decoded if it's not properly encrypted or not salted. So chances that the authorization in terms of attack surface can also get exposed through it. Test all APIs with the authorization, without the authorization first. I mean, like you have like a bunch of APIs. Don't send your token. Don't do any sort of authorization. If it starts giving you responses, chances are that unless it is a public API where it doesn't need any authorization, and it is for a general public use, all APIs must have some sort of an authentication so that you get authorized as to what sort of data you can actually get. And then look for hard-coded credentials in code. There are SAST tools which can actually help you find it. But you can also kind of do a grok on your code to see if there are any hard-coded credentials. And chances are that these hard-coded credentials might actually come up in a response later, who knows. And then for trial applications, use tokens once the trial period expires. And this is one of a very funny test to do, right? Many websites after a trial period might actually end up saying that, hey, your trial period has expired. But there are other APIs that the website might be using under the hood, which if you actually proxy and get the list of APIs, you might actually end up seeing that even after trial period expiry, you will be able to use it. So keep that in mind. And then when a website actually exposes a mass registration, like you can register through a CSV or through a JSON, make sure that the privileges that can be given are limited, and the number of admins that can be created are also limited. So chances that a user might end up creating a lot of admins, and the admins have a lot of ways to actually generate tokens, and this could create a lot of chaos where a lot of privileged users end up being there for a single organization. And again, that could also expose a privileged token over the web. So keep that in mind. And when it comes to testing your APIs itself, other than authentication and authorization, look at the endpoints. Try to add wildcards while testing the endpoints. Burp Suite has an intruder attack. I mean, Burp Suite is the security testing tool, which most of you would know. It has an intruder attack which randomly can fuzz these endpoints and then test for different conditions. And then it might also end up exposing limitations in your API. And then add vulnerable parameters, like let's say a list of users where it takes a parameter admin login. Give a non-admin ID and see what happens. And then let's say a particular customer can use this API user information. Give a user ID from some other customer. Do some guessing to see if some other user ID can be done. Since you are a tester and you might have this information already, try with different customers' user IDs to see if something gets exposed. And last but not the least, the headers. Headers are also an area where you can actually tweak a header. Let's say instead of giving a test application XML, you can do JSON, and then you can also give user is equal to test application XML, and then you don't know what actually comes back in the result. If the header is not properly validated by your what is that framework, chances are that it might actually end up giving out information. And then you can also try and give out a list of user IDs through the headers and see what comes up in the results, right? And then see different type. I mean, there are different parameter types, right? I mean, try sending XML requests instead of JSON in case if your API is expecting JSON. Also try sending JavaScripts instead of JSON, right? And see if the JavaScript can actually result in some exposure of data. And then look at the user IDs, like let's say instead of sending an integer, send a name and see what happens. Send a script instead of a value, where you might actually do a SQL injection to see whether it's actually ends up giving out all the users from the user table or the table itself in the return response. And change the request verbs from get to post or post to delete or post to put or put to post or something of that sort. So in this case, let's say you use delete instead of post and give a user ID. Chances are that the user ID might actually end up getting deleted. So there should be a responsible way to actually do this, and if your API doesn't do this, then and a delete without a proper authorization as well, then you're in a soup, right? So also look at routes. The routes should not be tweaked. Your API routes, endpoint routes has to be like consistent, and if something can be tweaked and get some and the user can get some information, chances that could also expose a lot of data. And in the response, is the API giving the right response? Is it giving too much information? Then that's a problem. Is the customer credit card details getting leaked? The last 4 digits is fine to be sent back, but what happens in case if the entire credit card details are actually sent, right? Chances are that a UI might be showing only the last 4 digits, but the API is actually exposing the entire credit card details, right? And then when it comes to personally identifiable information, which is PII, are the APIs up to mark in terms of not exposing the email IDs or the phone numbers of the users unless it is extremely important for the API to actually return? So look from that use case standpoint as well. Last but not the least, there could be outdated APIs. As you grow as an organization and over a period of time, you might actually deprecate a lot of APIs. But once deprecated, at some point there should be a sunset of these APIs. If not, you might end up leaving it for an attacker to kind of error guess it. They might actually, your version 1 of your login API might be using an outdated OAuth login, which might be vulnerable. So they might actually end up using this V1 login to generate a token, and then maybe use that to kind of access the V2 APIs with a newly generated token. So that could be a easy way to error guess as well, right? And then these days APIs are certificate pinned. So certificate pinning is nothing but the certificate of the host is stored locally by the client. So you'll have to download and install the certificate in a test tool like Burp or Fiddler to test it. So make sure that your APIs are certificate pinned, but it's again a company policy. If it is the case, then still go ahead and test it using the other workaround that you have. And here are some learning resources. Go to Burpsuit Academy. You have tons of courses to learn. Then use damn vulnerable web services. And there are a couple of blogs that I have listed here. This damn vulnerable web services will actually teach you a lot of vulnerabilities when it comes to APIs. And then the top security vulnerability resources, of course, you would know OWASP and CWE. These are top web service vulnerable resources to kind of learn security testing from an API standpoint. So that's all I had, and hope this session is helpful. Thank you very much.